Hello everyone, welcome to today's lesson with me, Mr. Roundy. In today's lesson, we're going to be learning to solve equations that have rational coefficients. Now, you might be asking yourself, what the heck is a rational coefficient? No worries, that just means it's time to review some vocab. So, what is a coefficient? A coefficient is a number that is being multiplied with a variable. For example, in the term 3x, the 3 is being multiplied with the x, but we read it as 3x. The 3 is the coefficient because it is the number with the variable. This means that in today's lesson, we're going to be dealing with multiplication equations because we're solving equations with rational coefficients, and the type of equations that have coefficients are multiplication equations. Now that we understand what a coefficient is, what is a rational number? A rational number is any number that can be written as a ratio. Now that may not make complete sense, so let's use this chart to help us make sense of it. This chart shows us the different kinds of numbers that we often use in math. The bottom circle is natural numbers like 1, 2, and 3. Notice there is no zero. Then there are whole numbers, which include the number 0. Next is integers, which include negative whole numbers. Then rational numbers, which include fractions and decimals. Anything inside one of these circles is that type of number. Anything outside of a circle is not that type of number. For example, the integer circle is inside the rational number circle, which means that integers are rational numbers. However, integers are outside the whole number circle, so integers are not whole numbers. Putting these two pieces of vocabulary together for today's lesson means that we're going to be solving equations that have fractions or decimals being multiplied with the variable. Whew! That was a lot of explanation. How about we look at some examples? We'll start out with a decimal example because decimals are really the easier of the two to have to solve. So our example problem here says 16 is equal to 0.25 times the variable n. And so we learned in a previous lesson that in order to solve an equation that is being multiplied, or a multiplication equation like we have here, that we're going to use the inverse operation or the opposite operation. So since we're multiplying the variable by 0.25, we're going to use the inverse operation of division to help us solve it. Now, the reason we do this is in any equation, when you're solving an equation, you're trying to isolate or get the variable all by itself. And in this case, we want to make it so that n is alone. And right now, it isn't alone. It's got this 0.25 sitting in front of it. And that means it's being multiplied. So we use an inverse operation to solve it, which means I'm going to divide it, and I like to use a fraction bar to show division. I'm going to divide this by 0.25, the number that I'm trying to get rid of. Now, if I do 0.25 divided by 0.25, that gets 1. Now, here's where we come into some math properties. 1 times n is going to equal n. And that's why my n is now by itself. I don't have to write the 1 in front of it because 1 times anything just gets me that number. That's the multiplicative identity property in math. So now I'm only going to have n on that side of the equal sign. But we learned in a previous lesson that the division property of equality says that if we divide something on one side of an equal sign, we have to divide it on the other side. So that means I'm going to do 16 divided by 0.25. This is where our calculator comes in handy. We'll just do 16 divided by 0.25 in our calculator, and that will get us 64. So now my problem has been shrunk down to 64, we've still got the equal sign, equals n. So the solution to my problem is 64, or n equals 64. I can always check to see if my solution is correct by putting 64 back into my original problem. So 16 equals 0.25 times 64. And I put the 64 in where the n went. Now I do 0.25 times 64 on my calculator. And if it gets me 16, I know my solution is correct. Our next example problem is a word problem. Jay's coach agreed to buy ice cream for all of the team members. Ice cream cones are $2.40 each. Write and solve an equation to find how many cones the coach can buy with $30. Well, the first thing we've got to do is analyze the problem a little bit. In the problem, it says that the cones cost $2.40 each, and that the coach has $30 to purchase ice cream cones with. When you're trying to write an equation, the first thing you always want to do is find out the variable, or the thing that you don't know. In this particular problem, the variable is how many ice cream cones were bought. We don't know how many cones the coach bought. So what we can do is create a variable for that. The variable we can use for this is the variable C for ice cream cone. Or you could have done I or any other letter that you want, X, whatever. I chose C for ice cream cone. Now that I know that the ice cream cones cost $2.40 each. So if I wanted to find the total cost of that, I would normally do $2.40 times however many ice cream cones were bought. Now, since I know that C is representing the number of ice cream cones bought, then that means I would write my equation as $2.40 times C would tell me the total cost of the ice cream cones. I also know that the coach has $30 that he can use to purchase ice cream cones with. So my 240 times C has to equal $30. And now I have my equation. Now that I have my equation, I can work to solve it. First thing I'm going to do is work to isolate the variable C. I can see that $2.40 is being multiplied with C, so I'll use the inverse operation, and I will do divide $2.40 to get rid of the 240 that is next to the C. The division property of equality says that I have to do that on the other side as well. So I'm going to do $30 divided by $2.40, and I'll use my calculator to help me calculate how much that is. My calculator is telling me that C equals, when I do my division, 12.5, meaning that I can purchase, or I shouldn't say I, the coach can purchase 12.5 ice cream cones with $30. And this would be the solution to my equation. For our final example problem, let's look at one where we have a rational coefficient that is a fraction. So here we have our rational coefficient is -7/9, and it's being multiplied with d. Now, in our previous problems, we used the division property of equality to get d by itself, or get our variable by itself. However, when we're dealing with fractions, we do things a little bit differently. So for example, if I had the fraction 1/3 and I was going to get rid of it, then I would just divide by 1/3. But if I write that out in our kind of normal notation, we would say divide by 1/3. And in sixth grade, this is kind of reviewing some sixth grade math here for us, we learned that when you divide by a fraction, really all we end up doing is changing our divide sign to times and flipping or doing the reciprocal of the second fraction. So dividing by 1/3 would be the same as timesing by 3/1. So in this problem, if I use the division property of equality to divide by -7/9, then really all I would be doing is multiplying by the inverse, or I should say reciprocal, which would be 9/7 negative. And so when we deal with these problems, kind of save ourselves from working too many steps, we call this the multiplicative inverse. We can get rid of a fraction by multiplying by its inverse, or its reciprocal. So I can get rid of negative 7/9 if I multiply by negative 9/7. And what this will do is cause my numbers to be canceled out by each other and leave me with 1. And from our example 1 problem, we know that 1 times d is just going to get us d because of the multiplicative identity. So I'm going to multiply by negative 9/7 to get rid of my negative 7/9. Now, since I multiplied by negative 9/7 on this side, I'm going to have to multiply by negative 9/7 on this side. And so I've got 5 times negative 9/7. I'm going to erase some of my marks right down here. We know that all that's left there is d. So if I'm going to multiply 5 with a fraction, I'm going to have to make the 5 a fraction by putting a 1 under it. Now I can do my multiplication. 5 times 9 gets me 45, and 1 times 7 gets me 7. And I had this fraction was positive and this fraction was negative, so when the signs don't match, I'm going to have a negative answer. So D is going to equal negative 45 over 7. Now, in some cases, textbooks and math programs don't like us to have improper fractions. So we're going to have to convert this to a mixed number. 7 divided into 45 will go 6 times, which gets me 42. So if I subtract 42 from 45, that leaves me with 3 left over for my numerator and 7 as my denominator, and my answer is still negative. So D equals negative 6 3/7. Well, everyone, that's the end of our lesson on solving equations with rational coefficients. I hope you were able to learn something. Have a great day.